We now discuss the solution of a problem from the section three-dimensional geometry. The problem is related to the concepts of planes. This question has appeared in the joint entrance examination main held on 29th June 2022 in the first shift. The given question is, let P1 given by the vector r dot the vector 2i plus j minus 3k is equal to 4 be a plane. Let P2 be another plane which passes through the points 2, minus 3, 2, 2, minus 2, minus 3 and 1, minus 4, 2. If the direction ratios of the line of intersection of the planes P1 and P2 be 16, alpha, beta, then the value of alpha plus beta is equal to. We are given a plane P given in the vectorial notation as the vector r dot the vector 2i plus j minus 3k is equal to 4. And we are also given a second plane P2, and the P2 is passing through 3 points. These are the 3 points through which the plane P2 is passing through. And the direction ratios of the line of intersection of P1 and P2 are given to be 16, alpha, beta, then required to find the value of alpha plus beta. That's our problem. Let's now discuss the solution of the problem in detail. We have the plane denoted by P1 whose vectorial equation is given by r dot 2i plus j minus 3k is equal to 4. We write the Cartesian form of this plane P1 in Cartesian coordinates, and that is the plane P1 is given by r is xi plus yj plus zk dot 2i plus j minus 3k. After taking the dot product, it will be 2x plus y minus 3z is equal to 4. We have written that 4 to the left hand side, and that is minus 4 is equal to 0. That is the equation of the first plane. We are given the second plane P2 is passing through 3 points with coordinates 2, minus 3, 2, 2, minus 2, minus 3 and 1, minus 4, 2. And we know the equation of P2 is given by, and we know how to write the equation of the plane passing through 3 points. And if x1, y1, z1, x2, y2, z2, x3, y3, z3 are 3 non-collinear points, then the plane passing through these 3 points is given by this determinant is equal to 0. The determinant, 3 by 3 determinant, first row, x minus x1, y minus y1, z minus z1, second row, x2 minus x1, y2 minus y1, z2 minus z1, the third row, x3 minus x1, y3 minus y1, z3 minus z1, that determinant is equal to 0. And we write down, and in our case, the first point is x1, y1, z1, the second point is x2, y2, z2, the third point is x3, y3, z3, and then it will be determinant of this one. Right. Now, after simplifying, this is the determinant. First row x minus 2, y plus 3, z minus 2. Second row 0, 1, minus 5. Third row minus 1, 0. The determinant is equal to 0. Expanding this determinant by its first row, we are very familiar with the expansion of the determinants. Then we get This is the expansion by first row. Simplifying, we get minus 5x plus 5y plus z plus 23 is equal to 0. That is the plane P2. And its equation is minus 5x plus 5y plus z plus 23 is equal to 0. Thus, we have the plane P1 and P2 whose equations are known, and we have to find out the line of intersection of P1 and P2 and find its direction ratios and equate it to 16, alpha, beta. From that, you have to find out the values of alpha and beta, and adding alpha plus beta, then you will get your answer. Right. We do it in the next slide. That's the plane P1. This is the second one, plane P2. And the equation of the line of intersection of the planes P1 and P2 is given by the equation of the first plane together with the equation of the second plane. That is 2x plus y minus 3z minus 4 is equal to 0 is equal to minus 5x plus 5y plus z plus 23. Together, they give you the line of intersection of the planes P1 and P2. But we want the equation of the line of intersection of these two planes in a symmetric form. By that, we will come to know what are the direction ratios. Agreed. To do that one, first we fix the value of z is equal to lambda. We fix it, z is equal to lambda. And we substitute in the above equations. Then you will get two equations in two unknowns, x and y. And we consider this z is equal to lambda is a particular value that we have put here. Agreed. Now two equations and two unknowns, and we apply the rule of cross multiplication. Now write down the coefficient of y 1. The coefficient and the constant of minus 3 lambda minus 4, and the coefficient of x 2, and the coefficient of y, that is 1. Similarly, for the second equation we write down. Now the rule of cross multiplication, that is this into this minus 5 into this, and x by this one, y by this one, and z by this one. Right. Now we do it, then we get, by the rule of cross multiplication, we obtain x by 16 lambda 43. That is 1 into lambda 1 multiplied by lambda plus 23 minus 5 multiplied by minus 3 lambda minus 4. That is 16 lambda plus 43 is equal to y by 13 lambda minus 26 is equal to 1 by 15. Right. So this will imply from this we want to write lambda. We want to write the lambda. So how do we write? So x by 16 lambda plus 43 is equal to 1 by 15. Then x will be equal to 16 lambda plus 43 by 15. And that is 16 by 15 lambda plus 43 by 15. Send that 43 by 15 to the other side. Then it is minus 43 by 15, and lambda value will be by 16 by 15. Similarly, y plus 26 by 15 by 13 by 15 is equal to z is equal to, so z is equal to lambda means z minus 0 by 1 is equal to lambda. Z is equal to lambda, z minus 0 by 1 lambda. So that is the one what we have written. And this lambda we have written in the denominator. X minus 43 by 15 is equal to 16 by 15 times lambda is equal to y plus 26 by 15 by 13 by 15 times lambda is equal to z minus 0 by lambda. That is the equation 1, and it is the equation of the line of intersection of the planes P1 and P2. It is a straight line passing to 43 by 15, minus 26 by 15, 0. And its direction ratios are 16 by 15 times lambda, 13 by 15 times lambda, and lambda. So the equation 1 is the equation of the line of intersection of the planes P1 and P2 in symmetric form, and its direction ratios are given by 16 by 15 lambda, comma 13 by 15 lambda, comma lambda. But the direction ratios of the planes P1 and P2 are given to be 16, comma alpha, comma beta. I think that is the thing, right? Yes. Given the direction ratios of the line of intersection of P1 and P2 as 16, comma alpha, comma beta. So equating the corresponding terms, corresponding direction cosines, you get 16 by 15 is equal to 6 by into lambda is equal to 16. 16 by 15 lambda is equal to 16. Alpha is equal to 13 by 15 lambda. Beta is equal to lambda. In the first one, 16 is equal to 16 by 15 lambda. 16 cancels. Lambda is equal to 15. The value of lambda we got. So substitute in alpha. Then you will get 13 by 15 into 15. That is 13. And beta is equal to lambda. Lambda is equal to 15. That is beta is equal to 15. What is that we want to find in this question? We want to find the value of alpha plus beta. Therefore, alpha is 13, beta is 15. Alpha plus beta is equal to 13 plus 15 is equal to 28. And that is the answer to this question. So that is the detailed discussion of the solution of the problem from the section 3-dimensional geometry, and the problem is related to the concepts of the planes. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.